Okay, we will start with doubly linked list. Doubly linked list. So we know how doubly linked list is represented. The node will have three parts. This is for left link, to store the left link. This is for the data, and this is for the right link. So this is how a doubly linked list node looks. Okay, for example, I can say like this. Here the data is 10, 20 and 30. Imagine this is at address 1000, 2000 and 3000. So what I'm going to do here left link means it stores the address of the node which is previous to this node. So there is no one to previous to this node, so you can put null. So this right link stores the address of the next node. The address of the next node is 2000, so you put 2000 here. So there will be a connection like this happening. Here when we go to this node, the left link stores the address of previous node. The previous node is 1000, so 1000 will be there. So there will be a connection like this, and here it will be 3000, so there will be a connection like this. And here in this node, the left link will be 2000. That means it is connected to the previous node. And here there is no next node, so it will be null. So this is an example for doubly linked list. Now we are going to see insert at the front, insert operation, which is insert at the front, insert at the end. Okay, so as previously in previous videos I have explained, insert at the front, we are going to have for insertion we are going to have two cases. Either your doubly linked list will be empty and you are trying to insert, or what is happening is there are nodes in the linked list. Okay, so now first we'll see. I'm just going to write function void insert front. As this is a doubly linked list, I'm going to give as DLL. Okay, now what I'm going to do is, imagine I want to insert the node 10 into a doubly linked list. Into a doubly linked list. So what is going to happen? I create a node called temp, and let it be 500. Okay, let the address be 500, and the data of temp should be 10, and the left link should be null, right link should be null. So this is the node I'm going to insert. So first I have to create this node. How to create this node? Called malloc function. How to call malloc? Struct node star malloc size of struct node. Okay, so what is happening? This malloc size of struct node will give me the address 500. Okay, give me the address 500, and that is typecasted into struct node star. That means it will have a data part. The memory will have a data part, a left link part and a right link part, and the whole name of this node is called as temp. Okay, that is what is being created here. And now what we are going to do is, here we still created only temp, we didn't put the data. So to put the data, so in this, see in this line what is happening is, it is just going to create a node, okay, with three parts. Okay, this is data, this is the left link, and this is right link, and it's going to give me address 500, and the name of this node I have given 10. Now into data I have to put the data 10. So how to do? Temp data is equal to 10, and make your left link as null and also your right link also as null. So this is how to create temp. Okay, so now next what you are going to do is, we are going to insert. So we are taking the first case. First case is our linked list should be empty. Now, if your linked list is empty, we know what first is always null. If your linked list is empty, your first is always null. And at the time, what is happening? This node which you have created, which is temp, the node which you have created, this is temp, 10, null and null. This is, and now we have to insert this node to the front. Okay, so if the linked list is empty, you know that at this node will be the front as well as this node will be the end. There is only no nodes. Linked list is completely empty and you want to insert this temp into the doubly linked list. So what is going to happen? This temp is going to be the only one node which is going to be there in the front. In case when you write insert at the end also, if the linked list is empty, this is the only node which will be at the end also. So here you can say what is the only thing you have to do here is, see, temp is, imagine it is 500 plus, only thing you have to do is put your first here. That means give your first which was null, put it as 500. So what this happens, this becomes a doubly linked list. So only thing is your first was null. Okay, we know your first was null. That is why first is equal to null, it came inside this code. Your first was null. Now you have to make your first as 500. That means your first should get temp's value. So just put first is equal to temp. So what will happen? Your first comes and points to this node which is 500. So this becomes a doubly linked list. So this is what happens if the linked list is empty. Now we'll go for the case 2. Case 2 says if there are nodes in the linked list. If there are nodes in the linked list, you can, how can you do it? Okay, so we'll see. Else, imagine you have already these nodes 20, 30, okay, and 40. Okay, and this is at 1000, this is at 2000, and this is at 3000. Okay, and now here this will become null. Here it will become 2000, such that there will be connection like this. Here it will be 1000, there will be a connection like this. Now here it will be 3000, there will be a connection like this. Here there will be 2000, connection like this is created, and this will be null. And first will be standing here where the value is 1000. Okay, now here what you are going to do, you are going to insert the node temp which you have created, is null temp, which is originally at 500. You have to put this node as the first node. So what are the changes going to happen? Here instead of null, what happens? 1000 will be given. So there will be a connection like this. Okay, similarly here this null will be going and we'll get 500. So there will be a connection like this. Okay, so and then this first will move from here and first will come here because this is the first node and it should get the value 500 instead of 1000. So this is what we are going to do to insert the node. Okay, so we'll see how this happens. Okay, so first what we are going to do is, here we are going to insert the node. So what, as usual, what happens, you can change this temp. So now your temp, this one you have to change it as 1000. So how will you do? This is temp link. Okay, temp link. What you do is you make it as you should make it as 1000, correct? So we will have a connection. So 1000, you cannot write 1000 in the code. What should you write? 1000 values there in first. So you can write this as temp link is equal to first. So you can write this code as temp link is equal to first. Okay, so what will happen? Temp link is this one. Here first value will come, which is 1000. So there will be a connection like this. Now you have to change this value. This value how to change? You can call first left link. Okay, for it is first left link. So actually it is null. Now you have to remove that null and you have to make it as 500, so that there will be a connection. So you cannot write 500 in the code. 500 value is holded in temp. So you can write first left link is equal to temp. So what will happen here? It will come as 500 and there will be a connection like this. Okay, so two connections are already formed. So let me write this. So next code will be first left link is equal to temp. After that, what will happen? Now you have to remove your first. Your first is 1000. Now you have to make it first as 500. That means your first should be 500. You cannot write 500 in the code. You can write first is equal to temp. So what will be the next one? First is equal to temp. So this will be your code for the void insert front. Okay, insert front of doubly linked list. Okay. Similarly, we are going to see the insert at the end of the doubly linked list. Always remember, insert at the end of the doubly linked list till here. Till here, the code will be the same because we are going to create the temp node, and then if first is equal to null, when the linked list is empty, that means that only one node called temp will be your front as well as your end of the doubly linked list. So here the code is same. I will be explaining only the else part. So let's see the else part. So this I'm going to explain about void insert end of doubly linked list. Okay, here till the first is equal to null, it will be the same. Okay, else. Okay, else imagine the temp you have created is something like this. Okay, here I want to insert at the end, so I'm giving a data called 50. So when you're writing your temp data here, just give it as 50. Your L link will be null as well as your R link also will be null. Okay, this is your temp. Let it be at 4000 suppose. Okay, so now hope you understood. Create your temp struct node star. Put your temp data as 50. Your L link, temp L link as null, and your R link also as null, and you check if first is equal to null. What will happen? Just put first here. Your first should be 10. If it is null, your first is null. So when we go to the else part, okay, else part means there are many nodes in the linked list. Okay, imagine 20 is there, 30 is there, 40 is there, 40 is there, and I want to add 50 at the end. So here first will be there, and let me put the address 1000, 2000 and 3000. So how this will be null, and here it will be 2000. So there will be a connection like this. 1000, there will be a connection like this. Here it will be 3000. Here it will be 2000, and here this is null, and first value will be 1000. Now you want to connect 50 here. So what are the changes? It should be at end of the linked list. So what will happen here? You have to have tens value, that is 4000. So there will be a connection like this. Similarly, here it should be 3000. So there will be a connection like this also. Okay, both are connected. So, and this is the only change value which you will see. So let's see how this will work. Okay, now here you know which is the in order to insert at the end, we have to reach the last node, and we know how we know that this is the last node by seeing the last node's R link will be null. So in order to reach the last node, as usual when we studied in simply linked list, we take a variable called last. So here what you can do is, first your last was null. Okay, now your last was null when it started. Now you have to put your last at 1000. So last will be last should come at 1000. So how will you write as the code? Last is equal to this 1000 value is there in first. So you can put it as first. Last is equal to first. So what will you do? Last is equal to first. Okay, now last is coming and starting here at 1000. Now we have to check whether the last link is null or not. We know that if last link is null, that is the last node. Okay, so check whether your last link is null. Okay, if it is null, okay, it is not null in this case. So what will happen? What you have to do, you can start this a while loop. While last link is not null, what you have to do, you have to move this last to 2000. Okay, last is in 1000 now. Okay, now you have to move last to 2000. So 2000 value where it is, in last of link it is there. Okay, in last of link it is there. Okay, take this last link 2000 and put it into last. So what will happen? So the last will move here. Okay, so you can write this code, last is equal to last link. Okay, last is reached. So now you check whether this last, I mean here it should be R link. Okay, whether this last R link is here also R link. Sorry. Okay, you check whether your last R link is null. Is your last R link null? No, it is not null. So what will you do? Take your last R link value, which is the last R link value. It is 3000 and put it into that 3000. You put it into last. So now your last will become 3000. So last is here. Now again you check whether your last R link, this one, whether your last R link is null. Yeah, it is null. So it will come outside of this code. And here what you have to do, now it is simple. Make your last, here the value should be what? Your temp value, which is okay, you have to make your temp value as 4000. So your last R link now should be what? Your last R link should be 4000 now. Okay, instead of 4000 you can write it as temp because temp's value is 4000. So when you put your last R link as 4000 temp, what happens? A connection like this is being created. Okay, so you can do last R link is equal to temp. So there is a connection. Now here also, this also you have to change. You have to make temp left link. Okay, your temp left link value should be what? It should be 3000. That is, there should be a connection like this. Like this. This is 3000. So instead of 3000, you can write it as last year. Okay, so I can write the temp link as last. Okay, so first a connection will be formed, and this is how you add you do the insert at the front of a doubly linked list. Okay, now we will move on to deletion. Deletion, okay, of a doubly linked list. Here we are going to study deletion at the front as well as deletion at the end of the doubly linked list. Okay, now here in deletion I always say there are I always said there is three cases. One is linked list is empty, where if linked list is empty, anyway deletion is not possible. Second is there is one node in the linked list. Okay, only one node is present, or their cases are there can be many nodes. Okay, so these three things we are going to see. For all deletions you have to consider these three cases. For all insertions you have to consider the case which I showed up. Yeah, linked list will be empty and there are nodes in the linked list is empty. See, your linked list is empty and there are nodes in the linked list. So these are the two cases for any insertion. And what we saw down, That is the case. Three cases are there for deletion. All deletions in English, in single linked list, circular single linked list, doubly linked list, as well as circular doubly linked list. So we can see how this is going to work. Okay. Okay. I'll just write the function. I'm going to delete from the front of doubly linked list. Okay. So in that case, let me see, linked list is empty. What is the first condition? I'm going to say that is my first case. Okay. So you know, when the linked list is empty, your first will be null. First is equal to null. This is your case. You know, when your linked list is empty, there is nothing to delete. So you can just write a printf statement, no nodes to delete. Okay. Now you have two more conditions, that is case 2 and case 3. So you start a else, and in that you put a if else. Okay. So now here, what is your case 2? Your case 2 is there are nodes in the linked list. Okay. There are nodes in the linked list. I mean, there is only one node in the linked list. Okay. So here there is, imagine there is only one node, and this is null, and here first is standing. Okay, imagine this is standing at 1000. Okay, this is the condition where there is only one node in the linked list. So what you do is you make this as temp. You make this node's name as temp. So how will you do? That means temp is also getting, temp which was null initially is going to get the value 1000 now. So how will you do this? So temp is equal to 1000. How will you 1000? We cannot write in the code. Instead of 1000, we can write first, because first also holds the value 1000. So this is correct. So first you do temp is equal to first. So temp is standing here. After that, what will you do? Before deleting that, before deleting this node, you have to print the data. So you can do printf. The deleted data is, before deletion itself we are writing deleted data. Okay, the deleted data is %d. You can write temp of data, and then what you do, you call the free function to free the temp. Okay, and after that this gets freed. When you call free temp, this gets deleted, but first is still pointing to 1000. That is not correct. No, now first should be null. From 1000, from 1000 it should be made null. Okay, because there is no nodes to point to. So first will be, so this is the case if there is only one node, but we have not written the condition. See, what is the condition to write if there is only one node? As you have observed, its R-link will be null. If your first R-link is null, you know that there is only one node. And if there is only one node, what you have to do, put temp, and then you print the data, free the temp, and make the first as null. Now imagine there are many nodes. Okay, there are many nodes in the linked list. So how do you write the code? Okay, so there are many nodes in the node. So imagine this is, so else means when you are going to have, in our doubly linked list there are some nodes. Okay, so imagine here this data 10, 20 and 30, and we have address here, it is 1000, 2000, 3000. Okay, and so this will be null as there is no node previously. Here it will be 2000, so it will be get connected like this. This will be 1000, it will be connected like this. 3000, so this will be connected like this, and this becomes as 2000, it will be connected like this. So this will be null. So here there will be first, which has the value 1000. So what is going to happen here is we have to delete this node, that is delete from the front of a doubly linked list. So you have to delete this node. So what are the changes happening? So you have to delete this node. Also the first should come here. That means first should point here. Instead of 1000, the value should be 2000. So, and then the another thing is this value should be null here. Okay. So these are the things which, what are the changes which should happen if we are going to delete from the front. So we'll see how to write the code. First, what we do is we always during deletion we use the function called free. So in order to use free, what we are going to do, we need a temp. So now we are going to name this node as temp. So temp was originally null. Temp was null. Now what you are going to do, we are going to make a temp as 1000. So instead of 1000, I can write it as first, because first value is also 1000. So I can write it as temp is equal to first. Now your temp comes here. Now what are you going to do? You are going to move first from here to here. How is this possible? That is, your first value, your okay, your first value, which is 1000 now, it should move from there and to go to 2000. So this 2000 value, where do you find it? Do you not find it in temp of R link? That is, I can write this as first is equal to temp of R link. Okay, so when I write that, when I give like this, first is equal to temp of R link, when I give, so first will come and be here. So now here first will be there, which has the value 2000. So this will go on for me. And then now what you have to do, you have to free temp. Before freeing the temp, you have to print its data. Printf the deleted node is %d, and you can write temp of data, and after that you can free your temp. So this is the code for before that you have to make this as null also. Sorry. So here before that you can do first of, this is first of L link. So we can put a first of L link as null. So this null comes here. So this is how the uh, this is how the code goes for delete front of doubly linked list. So now we are going to see how delete from the end of the doubly linked list look. See, from delete from the end of the doubly linked list will be first is equal to null also will be like this, and this till here the code will be the same. Till here the code will be the same. I will be only explaining the else part. Okay, so now we will see um, void, this is delete from the end of a doubly linked list. Okay, so whatever I have shown till that is same, and I'm just going to raise the else part. So in else part, it means that this is the case 3, that is there are many nodes. There are many nodes in the doubly linked list or linked list. See, imagine there are nodes like this. This is 1000, 2000 and 3000, and this becomes your first, which is 1000. Here this will be null. Here will be 2000, so there will be a connection. Here there will be 1000, there will be a connection. Here there will be 3000, there's a connection. Here 2000, there's a connection, and here it is null. So what is going to happen here? You are going to, our aim is to delete at the end. So this node, we know how we know that this is the end node, because it's R link. Its R link is null. So that's how we know that this is the end node. So you have to delete this. You have to make this as null. Okay. So these are the things you have to do when you are going to delete the node. Okay. So now we'll see how we'll do that. So in order to find whether, in order to reach your, now here you have to from the end. So imagine this is the linked list, and delete from the end means you have to delete this node. So what are the changes? What you have to delete this node, as well as you have to make the previous node of the deleted node as the darling should be null. So these are the things you have to do when you are going to delete the, when we are going to have delete from the end. So here what you're going to do, there is some change which is going to happen the previous node, and there is a, and the next node should be deleted. So here we need two pointers. So we can see first we'll start with temp. Okay, we'll have to point temp here. So how to do? Temp was null initially, now temp should become 1000. So 1000 value stored in first, so I can put temp is equal to first. Okay, then what I have to do, you know, if the node is reached the last node or not. How do you know? If your R link is null, it means that the node is the last node. So you check whether your R link is null. Okay, so for that you can start a while loop. You can check whether the temp R link is null. Anyway, here it is not null. So what you have to do, so before moving the temp to the next position, you start off with the next pointer called last. So last was null initially. Now last should get the value 1000. It's that means it is temp's value. Okay, because why we did not put it as first, because first is also having 1000, but this is temp is going to move, even last is also going to move. Okay, both are going to move, so first never moves, so it is better to take, put last instead of first, put temp here. Okay, so it will be last is equal to temp, and after that you move your temp to the next node, which is 2000. Where is this 2000 present? In temp of R link. Temp of R link. So here you can put temp is equal to temp of R link. Okay, again, so now your temp moves from here to here. Now temp became 2000. Now you're going to check again this loop. Okay, temp R link, which is this, is it null? It is not null. So what will you do? Last is equal to temp. So your temp value is 2000. So last will become 2000. That means you move your last here to here. After that, what you can do, take your temp R link value, which is temp R link value is 3000, and store it in temp. So that 3000 will get stored in temp. So now temp will move from here to here. Again it starts the loop. Again it will check whether temp R link is null. Yes, it is null, so it will come out of the loop. Now here it is very easy. You make your, now here this you have to make it as null. So here last R link, what you do is make it as null. Okay, it is made null. After that, before freeing this particular node, you print the data, printf. Printf, you can write the deleted item is, deleted data is %d, and you can write temp of data. After that, what you can do is you can free the temp. Okay, that is the code. So free the temp means this gets freed. So this is how the deletion from the end of a doubly linked list works. Thank you.